Hey everybody, Mr. Murray here, Mr. Murray's Mathland, and today we are talking about how to find asymptotes for rational functions, horizontal or vertical asymptotes. So let's just jump right into it here. Number one, y equals 3x minus 5 over 2x plus 7. This is an example of a rational function, a ratio of two polynomials. And a horizontal asymptote is all about how does the degree of the numerator compare to the degree of the denominator. And when we say degree, remember that is that highest exponent. And those are both x to the first. So in this case, they have equal degree. And when they have equal degree, and I abbreviate horizontal asymptote as HA, when they have equal degree, that means the numerator and denominator are essentially growing at the same rate, in this case a linear rate, and so it will have a horizontal asymptote. It will level off at the y value that is the ratio of those coefficients, of the leading coefficients, I should say. So in this case, that would be 3 over 2. There we go. This graph in the long run will be approaching a y value of 1.5 or 3/2. For vertical asymptotes are all about x values where the graph does not exist, right? It's that imaginary vertical wall that the graph does not touch. So to do that, you have to only think about, well, what makes a fraction be undefined? And that would be when the denominator is 0. So grab that denominator, 2x plus 7, set it equal to 0, and solve. And subtract 7, divide by 2, x equals negative 7/2. There's your vertical asymptote, there's your horizontal asymptote. I should also mention, though, that for vertical asymptotes, it will be wherever the denominator is equal to 0 for any x value that's excluded from the domain, provided that this quantity does not cancel from the fraction, meaning there's not an identical quantity of 2x plus 7 up here that causes it to cancel. And that will cause what's called a hole, and we will look at that in another video, actually. But let's take another look at a couple more examples here just so you get the hang of it. So this horizontal asymptote was because the ratio of the numerator was equal to the degree of the denominator. And so you take the ratio of the coefficients. And we're going to look at, well, what about when they're not equal degree? So for example, right here, number 2, you can see right off the bat that the numerator has a degree of 1, that's 6x to the first, and the degree of the denominator is 2. So if your denominator degree is greater than your numerator, which is the case here, and just think about what you're dealing with is that your denominator is growing at a faster rate than your numerator. X squared, in the long run, as you plug in bigger and bigger x values, if you plug in 1,000,000 and you square that, that's going to be huge compared to just 1,000,000 to the first power. So your bottom is going to be getting larger much faster than your numerator. So when that happens, your overall value of the fraction is going to be approaching 0. And that's always going to be the case when your denominator degree is greater than your numerator degree. It's automatically a horizontal asymptote of y equals 0. Vertical asymptotes, again, we're going to look at where that denominator is equal to 0, the x values, if any, that make this undefined, and this factors, little quadratic here, x, what multiplies to negative 18 and adds up to negative 7, be negative 9 and positive 2. So you'll have an excluded x value of 9 and negative 2, and neither of those cancels from the numerator, as I mentioned there. So this graph would have 2 vertical asymptotes, 2 VAs, one at x equals 9, one at x equals negative 2. Okay, so that was an example of the denominator degree was greater than the numerator for horizontal asymptote. There's a few different rules. If they're equal, you take the ratio of the coefficients. If the bottom has a greater degree, it's automatically y equals 0. Number 3, as you can see here, you might have been wondering, well, what about if the numerator has a greater degree? And that's what's going on here, degree 4 over degree 2. And so if your numerator is greater than your denominator degree, then there will not be any horizontal asymptote. Because what's happening is your numerator is growing at a faster rate than your denominator. So the overall value of the fraction will just keep getting larger and larger. So it won't level off. It'll take off and approach infinity or go down to negative infinity. So no horizontal asymptote on this one. And for your vertical asymptote, if any, we're going to set the denominator equal to 0 and try to solve. Now that does not factor, but it does have solutions. We're going to add 20, take the square root of both sides. Don't forget, taking the square root to solve an equation, you need to consider plus and minus the square root. And 20 is not a perfect square, but it does reduce to plus or minus 2 root 5, right? Root 4, which is 2, times root 5. And so this would have two vertical asymptotes, one at x equals 2 root 5, and one at x equals negative 2 root 5. And again, neither one of those would cancel from the numerator. There's not a factor of either one of those up there. Okay. So our last example here is, just kind of putting a few different things together. We've really just seen all of the possibilities for the horizontal asymptote. We've seen when the numerator is bigger than the denominator, there's no horizontal asymptote. If the denominator is bigger, it's automatically y equals 0. And if they're equal, which we've seen again, but here we're seeing it a second time, if they're equal degree, then they're growing at the same rate, and it's basically going to be take the ratio of those coefficients. That's what it's going to level off at. So 10 divided by 2, which is obviously 5. So there will be a horizontal asymptote at y equals 5. For vertical asymptotes, I'm going to set the denominator equal to 0. And if you factor that, the only thing you could take out is a 2. And then you'll have that. That doesn't factor any further, but if you try to solve that, you'll say, where does x squared plus 16 equal 0? Where does x squared equal negative 16? And right about now, if not prior to now, you should be saying, hey, this isn't going to have any real solutions because I'm trying to take the square root of a negative. That's imaginary. So this is a case when you would have no vertical asymptotes. And so there we go. The only thing I should mention is that there is another type of asymptote. You can have what's called a slant asymptote, and that's if the numerator is larger than the denominator by exactly 1 degree. So for example, if you had x cubed over x squared, that reduces to x to the first power. If you have x to the 5th over x to the 4th, that reduces to x to the first power. So that would be a linear thing, and that's what would make us what's called a slant asymptote. But this video is just about determining horizontal and vertical asymptotes. So hopefully you've seen a few there, just to give you an idea, to try to show you a few different examples. All right, hang in there and keep working hard, kids.